Welcome back to our next lecture in our lecture series entitled Stroke Made Simple. Today we're going to talk about the functional unit of the brain, the neuron, and we're going to have some objectives in this lecture. But before we start, if you could please click the like and subscribe button. I ask you to do that because it triggers the YouTube algorithm, making this video available to other people like you who may be interested in watching it. So our objectives are to understand the functional unit of the brain, namely the brain cell or neuron, to understand how neurons function, to distinguish between two different entities called ischemic penumbra and core infarct, and to understand the concept of collateral circulation. Remember, this lecture series is based on a book called Stroke Made Simple. This is a brief presentation of Chapter 2, but everything contained within this lecture is in this book. So the basic unit of the nervous system is the brain cell or neuron. The brain contains over 100 billion neurons, allowing it to transmit information quickly. Neurons have special properties that make them highly effective in transmitting information. While there are many different types of neurons in the nervous system, every neuron has three basic components, and that is these branch-like projections called dendrites, a cell body, and this tail-like projection called an axon. So again, these dendrites are tree-like extensions extending off the cell body, and here's the axon. So essentially, cells receive information through the dendrites and transmit it through the axon. Now these axons can connect to other neurons by a gap called the synapse. So neurotransmitters that are secreted by these different brain cells and neurons carry signals or transport information across these synapses from one neuron, the axon of one neuron, to the dendrites of another. Each neuron can receive and send millions of inputs to and from other neurons. This transmission between different neurons allows different parts of the brain to communicate with each other and with the rest of the body. Later, when we talk about the effects of neurodegenerative diseases such as Alzheimer's disease, we'll see that these types of diseases interfere with the transmission of information between neurons. Stroke does the same thing. When stroke destroys neurons, they can't effectively transmit information. But despite these special properties that neurons have, they have two major disadvantages. The first is they are enormously sensitive to oxygen deprivation. They can't live without oxygen for long periods of time. And the second is they cannot reproduce or multiply. This is why stroke is such a devastating disease. Strokes result from irreparably damaged, oxygen-deprived brain tissue. An arterial occlusion reduces blood pressure to the brain. We call that reduced cerebral perfusion pressure, causing blood vessels to dilate and increase their blood volume or cerebral blood volume. Diminished brain perfusion causes two separate patterns of involvement. So let's look at this image here. This is the internal carotid artery, and we're going to go over anatomy later. This vessel extending medially off the carotid terminus where the carotid artery ends is called the anterior cerebral artery. This vessel extending laterally is the middle cerebral artery. There's a clot here, okay? So this clot, this black line here, cannot supply blood flow. Because of this clot, this vessel cannot supply blood flow to this area of the brain. Because there's no blood flow going to this area of the brain, this is called a core infarct. It's irreparably damaged brain tissue. However, look at what's going here. Even though this vessel is occluded, we are rerouting blood supply to this area of threatened brain. This area of threatened brain, but not yet dead brain tissue, is called the ischemic penumbra. These vessels that reroute blood supply to this ischemic penumbra, this is called the collateral circulation. So essentially, a core infarct is irreparably damaged brain tissue, and the penumbra, which typically surrounds the core infarct, is salvageable brain tissue. This is threatened but not destroyed brain tissue. So again, when we see this occlusion, the tissue immediately adjacent to this occlusion is an ischemic infarct or a core infarct. This is irreversibly damaged or dead brain tissue. Surrounding this area, supplied by collateral circulation, is the ischemic penumbra. Why is it so important to understand these two phenomenon? Is because if we can remove this occlusion, and that's our goal in stroke treatment, and restore blood flow to the brain, we can save the penumbra. We could save this brain tissue. Yes, this person's going to have a stroke, but it'll be much smaller than if that stroke involved this penumbra. We show images of that in a second. So here we go. Here's a case where there's a core infarct and a surrounding penumbra, okay? It is of the utmost importance that we restore blood flow to the brain as quickly as possible. Why? Because if we don't reperfuse the brain, look what happens without perfusion. This core infarct gets bigger. It expands into that surrounding ischemic penumbra. And if we don't have reperfusion, we get a very large infarct here. As opposed to here, where if we could reperfuse the brain by opening up that clot, we can maintain the small size of that core and save this brain tissue, this area called the ischemic penumbra, from suffering a completed infarct. So this is just another example. Here is a depiction of a core infarct in the brain with a surrounding ischemic penumbra. If we could restore blood flow, yes, that central small region of brain tissue, the core infarct, that's irreparably damaged, that's not coming back. But look at this, we've saved all this adjacent brain tissue. This is threatened brain tissue, which is called the ischemic penumbra. Now, one thing to also know about the ischemic penumbra and core infarct is both of these cells are non-functional, but the cells in the penumbra, I think of them as sleeping. You could wake them back up again, okay? However, in the core infarct, these brain cells are dead. You can't wake them back up again once they're dead. So while these two areas, the ischemic penumbra and the core infarct, represent salvageable brain tissue versus irreparably damaged brain tissue, they present the same way. Both of these cells are non-functional, and that's why people have stroke symptoms, whether it's an ischemic penumbra or a core infarct, their symptoms are the same because in both cases the cells are non-functional. Again, the ischemic penumbra surrounds the core infarct and contains threatened, non-functional but viable cells that are still living, whereas the core infarct represents irreparably damaged brain tissue. So if we reperfuse the brain, if we take the clot out of the artery causing this stroke, we could reperfuse this penumbra and get this activity back, but we're not getting back the core infarct. That's irreparably damaged brain tissue, unfortunately. So again, if we could restore blood flow to the brain and recanalize that blood vessel by pulling out that clot, we can maintain the small core infarct. Notice the surrounding penumbra. If we do not recanalize the blood vessel with obstruction, this surrounding penumbra, ischemic penumbra, will go on to become a larger core infarct. That's why it's very, very important that we restore blood flow to the brain as quickly as possible in ischemic stroke. Now, the reason the ischemic penumbra converts into core infarct is, let's look at this again. Here's the internal carotid artery, okay? This is the carotid terminus. Medially, this is the anterior cerebral artery. Laterally, this is the middle cerebral artery, okay? This is an occlusion in the first segment of the middle cerebral artery, or the M1 segment. What's happening here is blood flow cannot go antegrade into the middle cerebral artery. So this area of the brain is threatened. In fact, the area immediately adjacent to this occlusion will probably have a core infarct. However, look what's happening up here. We're having collaterals, again, from the anterior cerebral artery to the middle cerebral artery. This collateral circulation maintains this ischemic penumbra. And the reason this is so important is this collateral circulation can only last for a temporary amount of time. We don't know how long it lasts. In some people it might be minutes, in some people it might be hours, and in some people it might even be days. But because we don't know how long this collateral circulation will support the ischemic penumbra, we have to intervene as quickly as possible. Here's another great example of this. This is clot in a blood vessel. Notice this, there's no collateral circulation, so all of this brain tissue is dead. This is a completed stroke or a core infarct. In this situation, we have a clot, and again, the brain tissue adjacent to it is an irreparably damaged core infarct. But notice what happens here. We have blood vessels that recirculate flow, called the collateral circulation, that supply the surrounding ischemic penumbra. Remember though, this collateral circulation only exists temporarily, okay, for a limited amount of time. It is that amount of time that we have to pull out this clot and restore antegrade flow back into that area of threatened brain tissue called ischemic penumbra. If we don't, this core infarct will expand and become larger and larger and larger. So to conclude, we went through a few things today. The first thing we discussed was the functional unit of the brain, the neuron or the brain cell. Remember, its primary function is to transmit information. Then we discussed the different terms ischemic penumbra and core infarct. Remember, the ischemic penumbra refers to the loss of functionality due to reduced blood flow, whereas core infarct means irreparably damaged brain tissue. The goal of all acute ischemic stroke treatment is to restore functionality to the penumbra, which is the threatened but still salvageable region of brain tissue. We do this by removing the occlusion within a blood vessel that supplies that region. Everybody has a distinct individual time frame during which the ischemic penumbra can be preserved. Why is that? Because everyone has an individual distinct collateral circulation that may last minutes to hours to days. The only proven method to preserve the penumbra is to reopen that occluded blood vessel that causes it. Well, I think that about sums everything up. If you enjoyed the information in this lecture, please make sure to click the like button and subscribe. And with that, thank you very much for your time.